All right, so let's look at example 2 here. Let's look at part 1 of it. So it says cosecant squared of x minus 1 over cotangent of x. And we want to prove that that is just equal to cotangent of x. So, do we want to work the left or do we want to work the right? Yeah, I think the left is going to be best. It's going to be hard to take cotangent and make it into a fraction, which we could do, but then it's also got to have a fraction that's got a squared piece on top. It's going to be a lot harder, I think. All right, so let's just work the left. So let's see. I can't do anything with that denominator, but there's got to be something for cosecant squared of x minus 1. Well, anytime I see a squared and a 1, I'm thinking Pythagorean identities, okay? So look at your Pythagorean identities. Do you see the one that has cosecant squared and 1 in it? Yeah, it says 1 plus cotangent squared equals cosecant squared, doesn't it? Can I put the cosecant squared and the 1 on the same side?
Yeah.
So I could subtract the 1, right? And so when I do that, I would get that cotangent squared of x is equal to cosecant squared of x minus 1, isn't it? But wait, isn't that what we just have circled over there? So what is cosecant squared of x minus 1 equal to? So I'm going to take that right there, and I'm going to rewrite that as cotangent squared of x. And then I'm still going to put it over the cotangent of x. But wait, I've got something squared on top and the same thing underneath. Can I simplify that? I can.
But
What's wrong?
oh, never mind.
Okay.
Where did you get the cotangent squared x from?
Because you see over here in my pink, with that cosecant squared of x minus 1 is equal to cotangent squared of x. Cosecant squared of x minus 1 is what I circled up there. So because they're equal, I can switch them out.
Yeah, no. Where did you pull the cotangent squared of x from?
It's the Pythagorean identity. It's the 1, 2, 3, the fourth line down over on the board. Okay? See where it says 1 plus cotangent squared equals cosecant squared? I just algebraically solved that to get cosecant squared and 1 on the same side. And therefore it worked out that it was equal to cotangent squared. Now, where we're at right now, guys, is the same thing if I had x squared over x. How would I simplify that? Yeah, I would take the square out of the top and I would take 1 out of the bottom, right? So we're at the same position here. So I have cotangent squared on top, which remember, I'm actually going to do it like this. What does it mean to be squared? There's 2 of them. So I could write this as cotangent of x times cotangent of x. And then it's still over that cotangent of x that's on bottom.
So they would cancel.
Yeah, then each one of the cotangents will cancel on top and bottom, and what are we left with? And that is what we were after, isn't it? All right, so I'm going to write cotangent of x. I'm going to show that it's equal to, because all I've done is bring this down. You could bring it down each time if you want to, but I typically don't. So we prove that they're equal, right? Now sometimes you'll see something written at the bottom. Sometimes they'll write like QED, or they'll put a little box or something like that. That just is like I don't remember which language it is. But it just means it's finished. It's final. I'm done. So if you see something like that, don't be shocked. It doesn't mean anything to problem. It just means that it's proven.
So I have to put QED.
You don't have to put the QED. Just so you know.